Hi, Raúl. Thank you for joining.
Hey, how's it going? How are you doing?
I'm great. I'm great. How are you?
I'm good. I'm good. By the way, I watched your
Nice.
talk. JV
Oh,
linked it to me, and it was amazing. Great job there. Like, I love your vision.
oh, thank you so much, man. Appreciate it.
Yeah, yeah, and also the delivery and the style of the talk. Like, the content and delivery were great.
Yeah. You mean the long question? The guys started to talk with each other. I was like, okay, thank you for saving my life. Go speak to
That's
each other.
great. Yeah. Oh, yeah,
Yeah.
yeah. I saw that kind of like in the middle of the talk. Yeah, yeah, yeah. That was a
Uh,
bit disruptive. Yeah.
yeah, it was really interesting. I mean, like I'm speaking, partially from frustration. Like Filecoin is my project. And
Yeah.
the other guy who's asking, actually, he was so angry on Filecoin, so he's trying to, says that there's no way you can do that, and I'm hopeless. And then the
Yeah.
other guy replied to him with a long talk, technically, like, no,
Yeah.
it's possible here and there, and so on. Um,
Yeah, yeah, yeah. Well, anyway, it's not ideal. Anyway, that like people don't really understand how those flows could work. So there's definitely work to be done there.
yeah. I
Yeah, I
mean,
think that we
look,
had a little bit of a hiccup.
generally speaking, there's a huge opportunity over here. It's just maybe sometimes people or the teams are usually busy with whatever in their hands, and because the AI
Exactly.
industry is just moving so fast, so someone has to,
Yeah,
either alert or just do it.
yeah, yeah. I totally agree. Totally agree. Well, sorry. Ahmad and I joined early, so we kind of like got the conversation going here. But yeah,
Amazing, amazing.
Mikhail, yeah, Parth, I think you organized it, so maybe take the lead.
No, no, absolutely. Yeah, just kind of falling into what Raul was saying. Like, I loved your talk, and obviously,
Thank
there's
you.
some things that we want to also like kind of share with you, and kind of how it will help both of us, especially IO.net, kind of like really expand on the vision that you've espoused there. So yeah, let's kind of get started. Really excited to meet you, by the way.
Likewise. By the way, I'm not connect the camera. I'm just trying to fix things here.
No worries.
But
You
we
were a
can
mystery
speak.
man.
Yeah. Thank you, Parth, Mikhail, and Raul. So where shall we start?
Cool. So maybe Parth, I can take the lead here. So this call, like the people on this team are working on interplanetary consensus, right? And this is a project that is also expanding in scope and in a number of places. We can walk you through that a little bit later. But I think the goal here is to really find a potential like joint collaboration on a number of places to really have explore the idea of having IO.net and parts of it use the IPC stack to implement and deliver some of those decentralized primitives that you potentially want to explore or want to have, like for example things like training sessions or inference sessions that are uh, built as ephemeral subnets, so everything that happens within them is completely kind of like coordinated in a decentralized fashion, and also provable and is transparent whenever anything needs to get audited, or like consumers need more transparency on how their workloads are being distributed across a particular subnet, how or particular members, how members are joining and leaving that subnet, what the fluctuation of compute assigned to a subnet, and potentially things like gating the membership of a particular subnet based on characteristics that the user has chosen when configuring their compute job, right? So things like, for example, you mentioned kind of like CPUs and so on. So one thing that we're also exploring is having the membership gating at a subnet level, so that validators and can join and leave, or basically join only if they are able to prove to the rest of the members that they fulfill a set of criteria, right? So like I think those are like some immediate things that came to mind when I watched the talk, and like I discussed this with JV and Mikhail and Parth. But like the spectrum is pretty broad here. I don't know how familiar you are with IPC, by the way.
Yeah. JV explained me a lot about it, but just like not too technically here, and he told me still about the roadmap, as if we wanna implement this, it would take a few months from now. Um, but overall, I've been only exposed to the Filecoin through JV. Like actually, I mean, I know Filecoin for sure. I'm just I have never been into the technical part of Filecoin before I met back in April. And from there, I was just so busy with basically, building up to all this infrastructure for the project since we're launching, by the way, in 10 days. So right now, I think like we're getting into the level where like things are getting more serious. VCs coming on board, partnerships and so on. Things are like, it looks like this is the next Ethereum in a way. I know
Yeah.
it's hard to say,
Yeah.
but it really
Yeah.
is.
Yeah.
How as of a hype, I mean, from the hype perspective.
Yeah.
Um,
Yeah.
so we just need to back it up with really great technology, more and more, and
Yeah.
just keep investing more into the technology, something that lasts for years and years to come, right?
Yeah.
So that's why
Yeah.
we were at the beginning of the project. We're like, I mean, we execute differently than the world, usually than the crypto world. Is like we saw an opportunity in the market, and the opportunity is people need GPUs. No matter how you prove their compute, doesn't matter. It's just they want GPUs, right? So that's what matters for now. And they also don't need one or two or three or 10 or 100 GPU. They need thousands of GPUs, and these GPUs should be clustered. And also there's availability issues. So yeah, they have to be, intercontinent GPUs in some situations. So that's what that's what people need right now in the industry. They don't need a way to verify how my GPU got, hired, not hired, whatever. Like they just want a GPU. That's like first thing first. I mean, as a high priority. So and then later on, yeah, like next step is okay. Sure, now we got the GPUs, and we're not changing the way these GPUs are providing compute. We're not introducing a new solidity. We're basically just giving people an experience that looks like exactly the cloud, but the GPUs are sourced from multiple locations, and we're trying to compensate these people in a very good way. Even the compensation to the owners of the GPUs is not only block rewards, it's actually mainly based on the payment that was paid for the GPU cluster at the beginning of the cluster booking. So it's not like net emission, some emission contract, and that's it, or something like that. Like we're mainly around like Web two in a way, like more to Web two. But the reason we did it this way is because we wanted to move fast and be the first in the market, and we wanted to provide an experience that attracts a lot of engineers and big startups that wouldn't change the way they book clusters or they interact with clusters or they deploy inference apps or they deploy training apps and so on. For example, Jensen AI, if you heard about them, the guys are bringing in a new solidity in a way. So the adoption for such technology, I'm not saying it's not important. I'm just saying it's the future. And now we are here in the present, right? So we need apps, we need infrastructure that works now. We need GPUs now. We need clusters now. We need distributed computing at mass scale now. Then later on, we can introduce, how I verified your compute, how I verified that this was computed for you with zkML, with whatever. But just the point is, I want GPU now. That's the point number one. So that's our approach in building. I definitely want to go fully decentralized. I definitely want to have, all this different backend technologies behind it that decentralizes, the way you mentioned the IPC. But we did that at the first priority when we started. Our priority was let's launch, get users, get a lot of money flowing in from, and pay to all these GPU owners and bring all big, huge name startups using our product. And later on, slowly in the back end, we moved to decentralization. And from there, sorry, it took me a while, but from there, like looking at all the community, all the different people trying to do things here and there, Filecoin seems like the most promising into as kind of a technology, let's say like technology and a community who knows what they're building. Is Filecoin mainly is the one that I want to, like I felt more into, like these guys are really building stuff. So yeah, that's why I'm so
Yeah.
interested to have this talk.
Yeah, thanks a lot for that intro. This is, and by the way, I totally understand the business strategy here, and it makes a ton of sense. There is an immediate opportunity to capitalize on, and like by solving a real problem that developers and ML people are having nowadays, which is the access to compute. And you have this like this distributed infra and decentralized infra. You just want to put it at their hands, and like this is the first problem to solve. This will validate as well that there is absolutely a need for this. And then while you stay committed to kind of like so the decentralization aspect and making things more more open and like potentially creating crypto economies on top of it, I think that is like I totally understand that viewpoint. And IPC is an emerging technology, and we have a very ambitious roadmap. Right now it's almost at its infancy, and Mikhail can tell you more about where we're at exactly in the next milestones and so on. I think what we're looking to establish here is potentially, with a more long-term view, a potential partnership on or like collaboration, or like see how we can mutually benefit each other on a number of fronts, right? So it's not just about like IO.net potentially using IPC subnets. One of the key characteristics that this tech actually gives over like other scalability technologies is the ability to ephemerally spin up and spin down subnets in a transactional manner. So you can represent like every job, for example, that the user submits can be a subnet, right? And like that subnet will be secured with a particular stake, will be secured with it can pick its own consensus technology, can pick its own like set of like gas parameters and a number of things. Like won't really get into that, but each subnet is highly customizable in itself, and it can have a limited lifetime, and it can expire by design, right? And this is a parameter that you set at the beginning, right? So I think like in terms of modeling, the mechanics of how the transactional like nature of what IO.net is building, I think it marries really well. That would be like potentially one area of collaboration. With IPC and the roadmap in the future, we're also looking to introduce the concept of infrastructural subnets. So these are subnets that provide services to applications that are running in a particular subnet topology. And I do potentially see IO.net being a provider or being a service, an infrastructure that users can deploy in their subnet topology and just have access to programmatically, start and stop compute jobs from smart contracts, right? So I think that would be potentially one area of synergy. And yeah, and in general, like everything related to, the Filecoin integration, of course, like this, compute jobs that run on GPUs need a ton of data, right? For like you run that compute on data, right? So hey, Ahmad, good to see you.
Yeah, joining
face to face. Yeah. So the first root net that IPC will anchor to is Filecoin, and we'll be developing the primitives to bring together kind of like the IPC consensus with the storage that Filecoin provides, so as to like kind of like create this unified space where you can have programs running on subnets that have seamless access to storage, right? So I think like the synergy there between compute and storage is very clear, and I probably don't need to sell it to you. And that is like one of the things that probably attracted you to Filecoin, right? Yeah.
So the question is, by the way, like just maybe give me, sorry for that, but like can you give me like small background on the connection between Filecoin and IPC? Is it a new coin, new chain, new protocol? Like how are things moving in that direction? Is it totally different? You guys a different team, or it's actually under Filecoin?
Yeah. So it's actually, yeah. So IPC is a technology that has been incubated by Protocol Labs, right? And this first application, we envisioned it originally as the means to further scale Filecoin itself. So we had this vision around regional subnets, topologies, and having Filecoin really mimic the federated and geographical nature of the internet. So you would be having storage providers with different quality of services sitting in different data centers that are able to aggregate and like form mini networks that together form join and kind of in a hierarchical nature form the backbone of they eventually converge in the backbone of Filecoin, where in this L1, the rootnet, where the accounting for storage and a number of things happen, but the operations and the markets and the storage markets and so on are pushed to the edges in this regional topology, right? So that was kind of one of the original inspirations of why we even started IPC 2 years ago as a research project, right? So it's technology that is being developed by Protocol Labs, and now we're on the path to productize it and really bring it to market. We realized that what has been produced here has very wide applications, not just on Filecoin. So we're looking to kind of expand there. We're starting with kind of those projects and teams that are close to the Filecoin ecosystem. So some initial adopters are things like, for example, Fluence, who are also doing doing compute jobs and so on. They're very close to the Filecoin ecosystem, and other teams around kind of the Filecoin sphere. Those are the initial ones, but of course we're looking to expand from there, right?
That's great. So so the IPC is like the IPFS, or it's totally is it something similar to the IPFS as of incubation support and so on? Is it the same?
Yeah. So right now it's transitioning from this research project into kind of a productization phase. And by the way, you mentioned Filecoin and how closely linked IPC and Filecoin are. I have been contributing to Filecoin for 2-3 years now. I led the FEM and since the creation, the inception to the deployment of the FEM. So I'm now working with the IPC team to kind of FEM is a critical part of the IPC roadmap as well. The FEM is as you know, it's built on this hypervisor inspired architecture, which allows a multitude of runtimes to mount on the FEM and to be able to run any kind of program essentially that you can run out there. Programs that compile to WASM, EVM smart contract, that is our first runtime, the one that's running on Filecoin. But IPC subnets will have access to being able to run basically any runtime on top of the FEM. So in terms of, so just to touch on kind of another point that brings these projects very close. But yeah, we're at that stage where we are starting to really look to the market and really deliver this to the market. So it's also looking beyond Filecoin.
Understood. Well, that's really interesting. I'm always in for new technology and explore new frontiers. Looks like you guys are doing great work here. So how shall we start, or what are the directions we should be speaking about to have an understanding of how could we work together?
Yeah, Parth, do you wanna kind of add some notes here, take it from here? I know that I've been monopolizing our side of the convo for a bit.
No worries. So Ahmad, basically what I've kind of seen from your talk and what you're looking at in the future, you want a kind of ephemeral access to GPU clusters, or at least GPU nodes, to assign specific jobs and then to kind of scale up, right? That is one of the things that you're looking at. What else are you looking at from maybe a hot storage perspective that maybe PL can help you with? Because we have a lot of projects and a lot of parts of primitives that are actually building on this. So you'll be able to build on that, not only just the GPU side, but the entire stack.
That's a good question. So I think let me just give you some background on IONET as of layers of IONET in a roadmap. And also I want to speak about something called the IOG, or the Internet of GPUs, and which is a research paper we're launching in 4th of December in Hong Kong. Some invention expedition and competition there. So for blockchain tech.
Interesting.
So I'm gonna talk layers on this. So first layer, we have the IO compute. The IO compute is the layer which has all the compute providers, including data centers, Filecoin SPs, and other consumer GPUs, whatever. Just whoever have compute supply. All this goes under the IO compute. Now the goal of the IO compute layer is to abstract the interaction and the drivers and the and all the basically build it's kind of like it's a layer on top of all these GPUs. Like, for example, render GPUs. They're Windows GPUs. I mean, they can't serve ML workloads and so on. And basically, and then there's the Filecoin SPs GPUs, and then there's the GPUs from some data centers. So all these different GPUs, they come with different drivers, different versions, different whatever. The goal of the IO, per compute layer is to basically abstract the interaction with all this compute in a way that it looks like a cloud, right? That's the whole goal, and incentivize getting more people into this layer. So, and these people, so for example, like Filecoin SPs, we're projecting 13,000 GPU right now from Filecoin SPs being onboarded. Like just one supplier from Filecoin SPs have 4,000 GPU. And so basically this, he brings his AMD GPUs, or he brings his, GPUs, he installs this, drivers and containers and so on his GPU. And the goal of these drivers and containers is to basically allow us to, book this GPU, monitor the performance of the GPU, containers. So basically it's like a Linux machine, right? So in a way you have a lot of room into abstracting installation of packages and drivers and so on. So that's the whole IO net compute. So our main goal was, let's bring as many suppliers we have. Now we're at 107,000 GPU committed to be part of the network once we launch. At the demand side, we have 20,000 GPU on this 107,000 GPU. So we need to work more on the demand, but we're just starting, right? So So we got all this compute. The two questions: how can we deploy things on this compute at mass scale? And then how can we incentivize people? So IO coin, ISD coin, we don't want to get into the coin here. This is the IO compute layer. Now, how can this compute be used in an enterprise level? How can this compute be used, by enterprises, by startups who care about security, who care about multiple things like geo-proximity, cares about storage, cares about, if they have NVMe or they don't have NVMe. So there's a lot of variables into when you have a lot of different GPUs on different locations, different types of GPUs and so on. So as the whole goal of IO, the first step in our roadmap is, let's bring as many GPUs as we have, but also let's make these GPUs capable of serving the needs of startups, which is basically capable of serving distributed computing, like the literal distributed computing, not the crypto distributed computing.
Of course.
So we install this Ray infrastructure on top of it, which is like a fork of Ray that compatible with multiple type of GPUs and so on, and for basically multi-network GPUs come from multiple networks. And just a side letter, Ray is used by ChatGPT to distribute over 300,000 GPU and CPU and 20,000 GPU. And Group is using it to distribute workloads across 500,000 GPU. Uber is, I think, 30 or 40,000 GPU. Instacart basically deploys more than 10,000 models using this infrastructure. So the Ray has proven itself to be the enterprise-ready distributed computing framework, right? So that was our approach. If we want to bring hundreds of thousands of GPUs, then it makes no sense to bring all these GPUs and then give people access to 32 GPU or 10 GPU or one. That's exactly not what the market needs. Well, maybe the amateurs or the indie developers or the small, really small teams, but when you start to scale, when you want to provide a service that could compete with AWS and so on, you need distributed computing layer that actually works with almost everyone who actually uses distributed computing, which is everyone who actually have mass scale apps. So we succeeded at that layer. We have now anyone who built a Ray app can easily change one line of code and he can deploy on our network, right? That's amazing. Like you just run the cluster, you have the options of multi-security, a lot of things, NVLink GPUs, a lot of choices on granular access, specific type of GPUs that you need. And then it deploys in like 10 seconds and it works. And everyone who's like ML engineer and does Ray is so happy. Trust me, so happy, including me, of course.
I can
because
imagine.
it's deploying clusters in 10 seconds. this is you can't find it anywhere in the world, and not even you can't find GPUs with like 100 200 GPU in a click. No, it's just deploying them in 10 seconds, clustering them together. That's a big deal for us. So why 10 seconds is important, then because you can auto scale easily, right? When you wanna add one more node, you don't have to wait 15 minutes for the node to spin up. You just have to wait 10 seconds. So this auto scaling thing is also something really important for us. That layer, IO compute layer, and then it's like, okay, so let's build now the IO cloud on top of this compute in a way. Like, how can we access this compute same way engineers are accessing, and even better UX to like, you know, DigitalOcean or this multiple, you know, cloud providers. I come in, I book not by how much my compute gonna cost me, no, by how many hours I need it, and whether you used it, you didn't use it, that's your business. So, and I think this is much better system to, especially for compute who really care about the kilowatt per hour on the GPU. You can't just say, you know what, I'm gonna give you a cost based on my estimation of how many T-flop we're gonna use and so on. Basically, like it's private information. You're not supposed to know how much Zarb is supposed to take. You're not supposed to know what packages he's using. You're not supposed to know all that. Or what you have, you know, you're just giving him access for the sub, let's say, from T1 to T3. And he has to pay for that time, whether he used it, he didn't use it, that's his business. The GPU was booked. If someone else could have booked it in this time, so it was given to someone else, so it's closed here. Like whether you used it or you didn't use it, as an engineer, the end provider of the compute has to be paid. Like you block time on him. And I think that's the most robust system to pay them. I don't think it's gonna change. Even the Lambda functions or whatever, it's in seconds, right? It's at the end, it's not like how much computing we can consume. It at the end is how much seconds I'm consuming from your GPU and wasting it instead of someone else could take it. The IO Cloud was built now. The experience is nice. There's a lot of components I want to add to the IO Cloud to give the ML industry users advantage. And here, there's two things. One that's connected to the IPC and one that's connected to generally the things that you ask me about what we need. So at this IO Cloud layer, and by the way, after that, we have the IO models layer and we have the IO apps layer. So at this IO Cloud layer, which uses the compute, the IPC connect, the thing that's similar to IPC is, first of all, so when nodes join the network, we create a new mesh VPN network for them, like a new cluster of like a new VPN, and then all these nodes behind NAT with whatever, behind firewalls, whatever, like because some of them could be they didn't configure ports, or some of them could be behind firewalls, or some of them different locations. Overall, you need some kind of just let me block this noise here. Yeah, so overall, you need some kind of networking infrastructure that's really robust, that could facilitate, allowing this. Sorry. Oh yeah, okay.
Just a comment on connectivity. Yeah.
So this network layer, by the way, and I see huge opportunity here. Just like we don't have time to expand there, and this is actually where you guys could step in potentially, is the bandwidth, right? The data and the internet transmission between like when I create this new subnet, or where all these GPUs just basically jump in this network, and they start to communicate with each other. Huge data in transit that's going through, right? And there's an opportunity, like we even thinking of having, like we have nodes that are providing GPUs, and we have nodes that potentially later on that provide storage, or let's say like hot storage, like in a way like ML CDN, and we have nodes that could provide this relay services, right, to transmit traffic quickly and to allow traffic to jump quickly between these nodes. So they're like network transmission nodes, and these nodes could be paid. Like they should be compensated for providing such mass high-speed relay services. And the Filecoin SPs, they have that. Like they also have that. If there's some kind of thing agent they install in their internet infrastructure and so on, could support them to provide such mass relaying service, right? And we need such relaying service when we talk about like mass clusters of GPUs and so on. You need such relaying service anyway. And by the way, like even Uber and Instacart, like they have to use multi-cloud. They have to use multi-region, multi-cloud, right? It's important because, first of all, sometimes, yeah, sure, they have partnership with Oracle Cloud or with Azure and so on, but all of them have different clusters on different clouds, right? And it's so much pain to connect these clusters from multi-clouds, especially with the data packets just get lost and so on. So there's a lot of things to enhance just at this side here. I saw there, but it's just like, okay, this is huge. Let's give it some time for now. Now, here comes on this layer. So when we create this new cluster VPN, and small long name short, it's a VPN for all these GPUs in the cluster. They communicate to each other. This VPN is supposed to be, destroyed in a few minutes, few hours, and so on. Like it's not gonna last forever, right? So actually, this comes right to the, comes just right to the word you said, which is to the subnet and the concept of subnet, because it is actually a subnet, right? Basically, here comes the IOG. Is like we're trying to enhance this mesh VPN network technology with like multiple relay servers in between. That are contributed by the people to enhance the speed and reduce the latency between the nodes. And this is like the paper I told you about on 4th of December, where we want to publish. So this, I call it the internet of GPUs. I know it's a cliche name, but it's really kind of the internet of GPUs here. And I hope there's a way we could like collaborate on this itself. Like it's something for me, I think it has a big potential here. But basically, I found out, which is really weird, that these these big enterprises or startups, they actually don't do that. Like they choose to suffer and rather than have mesh, what they call it, mesh data services and so on between all this. No, they rather just to keep it separated and siloed rather than suffer and put some proxy envoy in middle and all that to have this mesh services. Which there's some good services. I was working with a team from Kong HQ, if you know them, the one who built Kuma and multiple Kong API gateways. So they helped me on this, the mesh networking thing on how could you have mesh services. That was like back in February and March when I started the project. So I see there's a lot of room and research to be enhanced here and to actually reduce latency and yeah, engineers are still like, even though they're coming from ML industry, when I tell them, oh yeah, no, you don't have to choose this GPU from only Canada. You can just click Norway, and by the way, both of them gonna connect together. I was like, what? Even the ML engineers. So because usually like they're programmed that we shouldn't do that, we shouldn't do that, we shouldn't do that, we should for latency, network overhead, and so on. But anyway, when you scale, you have to do that. You don't have the choice. And this giving up on this, like having this network overhead, everyone has it. It's like everyone is expecting this network overhead. But actually, when you go to the Filecoin SPs, their internet speed is sometimes better than the internet speed when you speed test in Lambda Cloud and CoreWave, by the way. So that's an opportunity here. Like right now, I have one provider who was a Filecoin SP, and he built a Filecoin SP data center in Netherlands. Now they have $1 billion of infrastructure, GPU infrastructure. They have they're onboarding with us 20,000 H100 DGX NVLink. So this guy is crazy. I'm talking to him every day, and they're just crazy. Their internet speed too is like 2 times better than Lambda Cloud. And when we're testing with this YC start a few days ago, it's like, wait, why this is faster than Lambda Cloud? I thought this is going to be slower. Well, yeah, it could be slower, but you chose the highest tier with NVLink GPUs, who are all of them in the same data center. So you don't have to worry about speed, right? So that's also one choice there. Like you can choose when you book cluster on the network. So I think that's here for the IPC thing, or the how we're doing the sub networks. What was the second thing I wanted to talk about? Wait a second, I forgot it. Can someone remind me? I said 2 things here.
I think you said, I mean, maybe correct me if I'm wrong. Did you say IPC for like the subnet EBITs and then also like hot storage stuff? Was that one of the ones that you mentioned?
Yes. So thank you. So here comes, I said, so yeah, we're talking about the network and subnets here. Now he also asked me about the what are the products or the things that we need or we see we need there on this on the platform. and which is closer to hot storage and such concepts. So I think mainly there is huge opportunity in first of all storing the data sets. Storing the data sets for the engineer who's building a cluster. Like currently I'm building a cluster right now. I have to store things on S3. So, but why? Like, just give me the other choice that's cheaper. Just like, just give it to me. Put the just give me one choice and give me Falcon. I want to have the Falcon here.
Have you talked?
Just,
I don't know if you've had a chance to. I don't know. Actually, the people on this call have had a chance to chat with the Banyan folks. It may be worth connecting with them because I think it's like they basically are working to onboard a bunch of SPs, and they are just working on like, let's not even try to do like the market thing. Let's just get like flat rates where like this consortium of SPs just says like, we're signing up to offer at a specific price point. They're working on a hot storage layer so that you could do the caching that you're talking about, which like if your consortium of SPs is basically like, and they're also doing all the SOC 2 compliance stuff. So like that would work, Ahmad, for your platform. They're also using UCANs and WinFS. So there's an encryption story and like an access story that you could plug into as well. That may be the fastest path. I think I introduced you over Telegram. I don't know if you actually saw it.
Yeah. You did actually. We didn't continue the conversation together. She sent me things and I got busy last day. But
yeah, I know you're in raise mode. It's totally reasonable.
But I'm telling them like in general the few we should give some attention to, because if we group all this suite of things together, right, we really have a solid decentralized compute infrastructure, right, that actually works what AI startup need. That's my goal here. And AI startup are suffering. Like literally, the guys I'm talking to, like this, there's a YC startup we're talking to. They're building a new text-to-speech model, and it's this new stable diffusion model, kinda, and they're gonna be huge. Like these guys are very well backed. The owner of the model have 140,000 followers, the most famous in the ML industry. They are like, they tested the cluster. They were so happy. I was like, and for them to move from Lambda Lab to me was like this. Why? Because the UX, right? Because you have all that, everything. He said it, because you don't let me think. I don't have to think in the platform. It's so simple. Just tuck, that's it. It's up and it works. So how can we make engineers not think? Maybe that's not the right motto here, but better not to think. That help the engineer not to think. So of the not to think services that we should have is basically when I'm deploying this array cluster, I want an alternative to S3 that could have my data set stored, or it has my own and so on. This is critical. This is like critical ASAP, and that's it. That's the main point. It's a must. Then moving, and I want that to be through the platform, right? They come in, they use this, they want to store data set, they want to store checkpoints and so on. All that can go through their kind of S3 at IONET account. Then next step is the model checkpoint. This is which using a thing called ML flow. So ML flow, basically, when you're building this model or training this model, you use ML flow. It's some kind of framework and packages and so on. It's like a kind of platform that you deploy yourself. Where you find, so you gather the data, you put it in S3, you build the array cluster on IONET, you write your code all through IONET and so on inside the IDE we have and so on. You connect all the data here and so on. But then now, once you start fine-tuning a model, let's say you took a model from ChatGPT, from Hugging Face, and you just want to fine-tune it to have something better. Let's focus on a specific use case. Now, I would fine-tune multiple versions of the model, like just for me to reach to the end model that I like. I may have like fine-tune 30, 40, 50, 60, 70, 80 model, and each one of these versions I want to save just in case for some time, right? Or maybe for a long time. It's my choice. So imagine the data, imagine the model and the files you need to store and replicate it 60 times, right? So this is already annoying, and that's why like data center, I don't know if you heard, Latitude SH, one data center, this is like a cloud provider. They basically started, they invested 3 months of time and money to basically put NVMe storage more into onto these machines, because all the engineers complaining that 100 and 500 gigabyte is not enough. We need more. And we need also more to keep up, to throw our models and our checkpoints there. So when we need them later, we come back to it. So imagine the storage they needed to, they just have to keep increasing storage. It's just going to keep going, and more users coming in, more storage you need. It's just infinity. It's problematic. So, and there's no way like compress data. One day we may have a way to compress data like Piper from Silicon Valley show. But until then, sure, not no way to compress data, but there's no that way that would reduce the data so crazy, right? So eventually we still need that, a lot of storage here. Yeah, basically that's the thing is like that, just this ML flow checkpoints thing. It's a huge opportunity of things that we need to store, and the ML engineers quickly. Like the thing is, it's not like you're gonna archive it and like every day you storing 3, 4, 5, 6 different checkpoints, and these checkpoints are huge. And also sometimes you do that checkpoints for a model that is already running for inference, and you want to keep fine-tuning the model, right? Each few hours or each few days you need to save a version of the model. You need to save a version of the model if it's being fine-tuned by the user data. So you could revert back to the original model and so on. So imagine the storage needed here. It's crazy and massive. And that's why I think it's a huge opportunity for us to tackle on. And that's why I want the IO cloud. When you go to the IO cloud, we have now the Kubernetes cluster, which is, use cases open. And we have the, Ray clusters. We have the PyTorch FSDP training. So all that can serve end-to-end ML workloads. Just now, next, we have to have a storage layer in the sense of, like ML flow checkpoint, Airflow, multiple different services that complement the experience of the platform. So the engineer, right, and use something else. If I could come in here and have everything so simple and easy to use, drag and drop, checkpoints connected directly to my Ray cluster from the IO cloud, all these different small features. This is really nice. I think that's like for the IO cloud layer. I think that's mainly it. Now there's one thing. Your turn. It's in my mind. I won't forget it. So yeah, Jamie asked.
I'm wondering, the relay stuff that you're describing, is that like, if we're talking about like bandwidthy things, that feels like that could also be something, maybe, I don't know if Saturn and stuff makes sense here, but like that feels like a thing that other networks might also benefit, like the other CDN networks that are trying to build on top. So like Titan, I think you guys were talking to as well. Maybe there's an opportunity to collaborate there where it's like they may want to use the same sort of like infrastructure as you guys.
Nice.
Yeah, there's definitely kind of like a common core here, which is like, how do you shuffle and move data around, and how do you place that data? How do you construct the optimal path, right, such that it will get you like lowest latency and highest redundancy and things like that. Like you really need to, like, at that level, there's probably like some common structures that like in room for collaboration there. I think they're more focused on kind of like, the traditional CDN delivery, market. So that is where, these things could differentiate, but yeah, there's definitely some common substrate there. And also, like, much of this could like be powered as well by IPC subnets themselves, right? So you can imagine like relay networks, or kind of like participants in the relay network grouping around particular geographies and really forming those fluid kind of like membership networks where they move from one place to another, and they're reorganized based on how the underlying internet infra also changes every day, right? So like, latencies and volumes and things like that on the physical internet infrastructure also determines like, what today's latency is with like, between a particular any two, like a path between any 2 points, right? So that's pretty that's definitely interesting. And maybe just to touch on the point of subnets, I think there's kind of like two angles here. There is, on the one hand, IO.net actually being a service that IPC apps can provision on their subnet topology to gain access to to basically send workloads to IO.NET and kind of like create and bootstrap a ephemeral network there that then like produces an output and that the app can use later. That is like one angle, and the other angle is actually IO.NET using subnets as well to organize the workloads and the placement and kind of like, to in the future roadmap for like, decentralization and transparency and openness and so on. Like, for example, to give transparency on accounting and on membership and like on quality of service and stuff like that, such that all of that is auditable to like, the party that actually did schedule that work, right? So it's kind of like a bi-directional usage of subnets there.
Yeah, payments thing also is really interesting. I know like this is going to show up in more than one place. So that might be even a different subnetty thing to think about. Again, all this is like UX contingent, but like, yeah.
Yeah. Very cool.
But simplest first, I mean, I think the most important thing is like, I thought, Ahmed, you put it well, where it's like, let's figure out how we can make sure like AI companies are actually successful. Once we have like a giant truck of like people trying to use the networks, then we'll be in a good spot. So as much as we can try to like fill some of these gaps and then build out the pieces that we need as we go, that'd be great.
Yeah.
So how should we start collaborating on this? What do you think is, first of all, do you think it's the right time for us to collaborate, considering like how do you think of this?
Yeah. So there's a number of things I'm seeing here. I think we should definitely start collaborating and sketching out some of these ideas and kind of like, what the opportunities are here and then timing them, right? Because like the IPC technology is maturing. It is also, like, as I said, in early stages, right? So like we absolutely want to make sure that, the technology is ready to support the scale and the use cases, but that also informs kind of like, priorities on our side, because like if we really think that this partnership could be super fruitful, then that will like, could reprioritize how we're thinking about our roadmap as well, and in terms of like, partnering together and like really delivering killer use cases with like, the joint set of both things. So I think we should get a doc started there to list out these opportunities and start sketching out what all the different angles, right? And then alongside that, I think JV, like, there's a number of useful connections here to like, to facilitate as well. Like you said, you already like are in touch with the Banyan guys, but maybe the Saturn guys, and we can be present as well to kind of like figure out how also like IPC slots into this common core that would be like, the infrastructural and networky side of things, right? And how it can be used to organize those flows there. So maybe we organize a call with the Saturn guys as well on like, so that you can like also understand, Ahmad, like where they are and kind of like how they're thinking, because the problem sets and kind of like, are similar, right? So I think that would be useful.
Yeah, I think for what it's worth, my sort of pitch would be like, we should do like the intros and stuff. I think the Banyan one, my sense is like, there'll be the fastest to get you something that you can use for like the hot storage piece. And like, they're willing to do custom stuff. So like, especially for getting something that we can like take to market quickest, that might be the thing. But everything is content addressed. So like if in the future, the idea is like, hey, we want to move off of Banyan, or like we want to add Saturn as another option. Like, I think the most important piece is like between the different teams that are offering these like retrieval sort of, or like hot storage layers, make sure there's just some like a simple common API that like IONet shouldn't care actually so much. It should just be like, hey, look, here's a bunch of things that you can throw into, and it's like, what just is, like ideally this isn't like that big of a decision. It's like pick a provider. It's the same way that you have like render GPUs or like Filecoin GPUs. It's like, do you need something that's SOC 2 compliant? Here's a bunch of stuff, and like you just have a checkout cart.
Nice. Yeah, that would be actually a good experience to have. The question is like how this, so what is the connection between Banyan and IPC? What do you guys think? Or like this and that, how could it block like a Lego? What do you think?
I mean, I don't know if you've chatted with Banyan yet. You guys actually probably should chat with Banyan about their longer term roadmap stuff. But like,
yeah,
my general sense of like the things that they want to build is like, they're trying to basically enable people to get like the S3 part working on Filecoin. Like just get a thing working first and then like start building networks on top of that. So like if you want to like create subsets of the network that's like just SOC 2 stuff or like other requirements, people have the ability to build up those things. They're focused very much on like how do you build this with like the WinFS and like this like UCAN things. So like it's not like you have a Banyan server who's like in charge of auth. It's like the data sort of like self-encapsulates like who is able to like access XYZ.
Yeah, we should definitely connect with the Banyan guys too. Like, understand the last time I spoke to them was like a few months ago, and I know they've kind of like pivoted a number of times and kind of like, you know, figuring like refining the roadmap. So we definitely should connect with them. Let's create some room for that.
Raúl and Parth, do you guys think we can through the subnet he mentioned like SOC 2 and so on, do you think we can have subnet rule that allows subnet to talk to other subnets if they match certain criteria? Like a SOC 2 subnet can only talk to a SOC 2 subnet and transmit data only through from a SOC 2 to a SOC 2 subnet, but not from SOC 2 to non-SOC 2 subnet. Do you think there's something doable with the subnets?
Yeah, I mean, I think there's a possibility there to construct a handshake protocol, and this would be more on the lower level, on the networking level, right? That would, like, maybe at the consensus level, there is like some kind of transaction that establishes a gateway or a tunnel between any two subnets where like is determined, the capability to establish that subnet is determined by smart contract logic. So it cannot be changed, it cannot be gamed, right? So you have, if you can provide like maybe some ZK proof of like some characteristic that would then allow you to establish that tunnel, right? Then that could be validated by the smart contract. It would allow it. And maybe like that would emit locally a secret or something like that, that both that would not get posted on chain, but the local nodes would be having access to that secret or something like that, that would then allow you to establish a channel, a secure channel between those subnets. Like I'm just thinking out loud and kind of like, you know, brainstorming, because these are two different layers, right? So there is there's the chain, on chain, kind of like, you know, verifiability, decentralized network sort of like logic, right? And then there is the networking, what happens at the physical networking layer, right? Because you need like very strong guarantees on Sec2, like on these compliance things, right? So yeah, just thinking out loud. But I think that's another angle that we can explore for sure. I'll add it to the list.
I think that's an untapped angle, because if somehow, just like HTTPS, you know, in a way where I can only allow HTTPS to talk to HTTPS or some specific protocol in a way. If you can have a protocol that can allow certain, you know, security certified cluster of networks that actually speak to each other only if they match this minimum level of criteria, that's something big. It's not small.
Yeah, that's pretty cool. Yeah,
I need to have maybe one thing we should also. I can flag this to the DSA people. I think we also need to figure out like some standard for verifiable credentials on like, right now, I think as far as I understand, everyone's kind of doing one-offs on their certifications. And so like you have to go talk to the miner. We need something that's like discoverable so that like, Ahmad, if you want to like spin up a subnet that says, if you have a verifiable credential that says Ernst & Young, KPMG, some set of trusted providers, like has given this attestation, then like they're allowed in. But I don't think we have that in a discoverable way just yet.
Yeah, and that can be the component by which the input by which you gate the membership on a particular subnet that groups, you know, compute providers that are compliant with some particular thing, that are sitting on a particular region and are like, you know, have a particular kind of GPU or whatever. Like, I think we need to build, like, ideally we would build those credentialing mechanisms as well for like technical characteristics as well. So for bandwidth and for like, you know, the technical spec of a particular data center or particular provider, the GPUs and the, like, if you're able to extract a fingerprint, right, of like their deployment, like their data center characteristics and features, and you can verify that in some way and you can attest it, then you can provide like a lot more transparency as well to the user, and
Yeah. No, if just to give you a quick background on how important this is, maybe because the thing is, the first day I started the project is I spoke to a friend of mine who built a 60 million data, 60 million. Well, when we first spoke, he wasn't my friend, now his friend. So he had a 60 million. They built a stable diffusion model, really famous one, and then they invested $60 million to build infrastructure for the RTX 4090, their own data center, because they were worried about hosting it anywhere else for security purposes. But even that wasn't enough. Like even if all that what they invested, they still needed another 40,000 RTX 4090, and he was like so desperate. But he has like really important two things, right? It's number one is the internet speed, of course, because it's going to be multi-region, right? Multi-cloud together, which opens a gate for like we really need very solid VPN technology that's maybe utilizing WireGuard but much more enhanced and so on for such large scale use cases, right? Current technologies, we tested almost everything in the market. It fails. Like it fails at a certain point when you are transmitting so much data. There's just that threshold, and then you're out. It's nothing works. We'll that back to the relay networks.
That's very sad. That's actually very sad. I mean, I thought the state of VPNs was definitely a lot more stable by now. But with was this thing that uses WireGuard that became Tailscale, right? I thought like.
Exactly. We were using Tailscale at the beginning, but Tailscale fails when there's data packets. Like I think more than a few megabytes, and then it can't handle it. Especially when you're using ports from one device. When you're multi-ports, each port like transmitting 50 megabytes or something, it fails. It can't continue. It can't do that. But rolling back here, so. The security thing is like everyone's so worried about, okay, like eventually I have to send my model somewhere for it to compute for large scale users. So they wanted 4,000 GPUs that are in another data center if I could find, or maybe 5,000 here and 10,000 here and so on. But what's his most concern? Let's not say SOC 2, but let's say what's really his concern is how can I secure my model at run in the memory of the GPU? That's like the industry most problem to be solved. If someone have fully homomorphic encryption for ML models at the same speed of current models, you're going to be the next trillionaire. So that's like a big thing everyone would like to solve, because then you can run models on untrusted devices and not to worry about SOC 2.
Exactly.
So the question is
because they're sorry, go ahead.
No, sorry. Let's continue.
No, I was just gonna say. I mean, I guess this kind of like even compounds when like you're using placing your models in not just untrusted hardware, but actually hardware of like people and providers you don't have a pre-existing contractual relationship with, but they're just brokered for you and they're participating in a given session, but like there's no, you might not even put a face to, or you might not even put an identity to who's behind, right? So I guess like, at the end of the day, models are in many cases part of like, the key, like most secret, like the secret sauce of many companies, right? So I can imagine it is
man. Imagine he literally he took this 60 million data center, he built it himself. You know why? Because I can go literally to the door and put my fingerprint, and only me open the door that access the GPUs that have my model. That's how much they really care about this model. They're so afraid because gone.
That's
the whole company is gone. If it was leaked, that's it. Like their business is dead. Can be leaked. So they're so sensitive about it, and I think this type of clients is really hard to serve, almost impossible. They're kind of like governments, right? They really it's like government, like military, like the military. So it's so sensitive to point that has to be fully air gapped and etc. There's multiple things here. So that's an interesting approach. Like, is it even a problem that we should be trying to solve for such mass scale who's so worried about the model? But then if you look at the other side, actually, if at least if you could say, so there's this new concept I suggest you guys look at. It's called sky computing. Have you heard about it before? It's a new terminology.
Yeah.
So this it's this new professor from UC Berkeley who built Ray, basically the guy who built Ray, the crazy guy. He came up with a new technology called not new technology, but like a new vision of the future, and some kind of an architecture called sky computing. And the concept of sky computing is basically we are moving to a future where there's a lot of cloud providers, and there will be more and more cloud providers. And since compute is commoditized, cloud providers would compete on who could provide cheaper service. So the concept of sky computing is basically to abstract whole cloud interactions into one single API. And I could submit my job, and then there's this system AI that's predicting and trying also to find me the right place to execute this job at the cheapest cost right now.
So it's doing the brokering as a man in the middle. Okay. Smart.
Yeah. So a one layer that broke all cloud.
I love it.
Wow.
I love how
Yeah,
these like ideas for businesses and kind of like just compose one after another in a layer. Like next thing you know, after like a few decades, that would be like a multi-cloud sort of like thing that like routes between different multi-sky, multi-something. Yeah. Pretty awesome. That's actually
but the thing here is like. But this kind of what this IONET is doing, by the way. So because we are abstracting the interaction with all these mining facilities, all the miners, all the multiple data centers, cloud providers, and we're sending, we're bringing you GPUs from all these places, right? But then if I would tell you right now, like, okay, look, I have the sky computing platform. It has Google Cloud, Azure, AWS, another 10 companies that we all know. You wouldn't even think of security, right? It's not even something that will come to your mind. Would my model be hacked? Well, not if you're huge, but let's go normal, like small size, no usual size, which is our target. Like from who needs from 100 to 20,000 GPUs. This is who we are targeting, like this range. So these guys, maybe after 10,000 GPU, they start caring about security so much. If it's some really high end, there's some secure data happening and so on. But before that, like they don't even think of security. Like it's not even something they think about. Even if they're building something great and they know their model is amazing, they just don't know what's even SOC 2. So, but once you raise VC funding and you have a lot of money, then VC starts to tell you need to be SOC 2 and advisors and so on. So you understand that you just have to comply with SOC 2. We have a compliance officer and so on. So then you become forced to find SOC 2 GPUs. But you wouldn't even think, does actually AWS has SOC 2 or not, right? We don't even think that.
Yeah.
Right. So
exactly.
That's the thing here. So in a way, if this network could prove in a way that this is secure, like these subnetworks or clusters or whatever subnets once they're created, even you don't even have to worry about your data being sent to another worker who is not SOC 2, for example. All the networks, when they communicate each other, I'm only authorized to interact with a SOC 2 network to a SOC 2 network, and not even the creator of the network can change that. Like that's it. This is SOC 2. This is SOC 2. Only those two guys can communicate if they need to communicate for one point of time. So the
subnet can choose to either use these as validators who are SOC 2 compliant. Yeah, we can have a flag, which is a requirement. Yeah, at the node level. Yes.
At the node level, at the subnet level, because do you guys inter-subnet communication or there's no subnet communication?
Yeah, that's the plan, of course. Across subnets as well, because we envision this as a hierarchy of subnets as needed. So definitely the message passing would be.
Yeah, I saw this speak from. Okay. So
and this is also like part of like that particular the communication across net comms is also got like one of those items that is gonna continue to evolve. So right now it's got like basic in the sense that messages travel up and they travel down across like the tree hierarchy. But then there will we're working on models for direct communication. We're working on models as well for atomic transactions and things like that. So the whole like cross-net comms will in itself evolve.
Yeah. I guess how to say cross subnet to subnet communication is critical. Because I would use one subnet from your side, for example. So I can roll my own subnet, right? Like a new subnet, right? So yeah. So then each cluster will have a subnet,
Exactly.
and then I would have clusters usually. This is a new thing we're building.
Yeah, and like this is so. We need to like figure out the timing on things as well. So I think a really good next step is to kind of like start fleshing out these ideas and these like ideas in a doc that we can collaborate on and sketch out all the areas where we could like our technology together would like make a dent and really be useful like to marry them. And then we can take it from there. I think like one thing that I do want to note is like the stack is evolving, right? And the tech is evolving on our side. So many of these things that we're talking about are possible, but the DX is not great, or they're kind of like features that are still like, make the experience kind of like a little bit slower. So like we also need to, as we kind of like, develop these ideas, figure out the timing element of like, I think there's like a general collaboration framework that we can create here, right?
Great.
Of which like we figure out the timing of like the different elements such that, that especially with like people like IO.net, we want to make sure that the technology is also like super mature, stable, and audited and like, a number of things there. So, gotta time each one of these.
Understood. Yeah, perfect. I guess good start.
Yeah.
I checked by the security enclaves Mikhail shared. Looks interesting too. It's more SGX, like it's the confidential computing tech, I guess. Yeah.
Are you gonna be in Istanbul in the next weeks?
I don't think so, because the team is so wrapped up with the breakpoint. We're launching in we'll see. You guys are, I think, breakpoint after you are in mid-November, right? Or
mid-November. It's gonna be between the 10th and the 19th. We're gonna be there. I'm definitely gonna be there. I'm also going to Istanbul a little bit earlier, so next week I'll be in Istanbul in case you happen to be there. So I mean, just to kind of like
if I was there,
as well would be great.
Yeah, I'll ping you. There's
a
big potential here.
Okay, cool. Yeah. By the way, can you what's your contact details? What do you prefer? Telegram, or the Signal, other things?
I use Telegram very often, so Telegram is good. If you guys want to go Slack, I can do Slack, but for me, Telegram is great.
I think Telegram is fine. We can adapt there. I'm definitely, usually on Falcon Slack. We're mostly found on Falcon Slack, but I get spammed all the time on Telegram. But it's fine. I'll do that for you.
I do both, Slack and Telegram, whatever you want.
Okay, cool. So maybe
have a
Slack
channel going on. We can add you.
Okay, cool. Yeah. So let's just keep it on Telegram for now. I think what we'll do next is spin up a doc so that we can explore these opportunities and figure out the timing as well. Another thing that we can do is maybe set another checkpoint in 2 weeks from now. What do you guys think? So that we keep the momentum up.
Yeah, sure. That's a good one. I think also the document helps us to put things in urgency as if like roadmap.
Nice. Yeah, exactly. I mean, for me, this was like a really great discovery call. I mean, there's a lot that
I
wish for me to parse
I wish this call was recorded as a video and published to the community. Trust me, people will be like, going through all these different ideas we're having here and there, and it's like, really
mind blowing.
Yeah,
exactly. Yeah. This is how big ideas. I think this is how big ideas happen, right? Like you just like talk about them, and like they just emerge from these kinds of like loose conversations.
Kind of like a podcast, by the way. Kind of just speaking here and there.
Totally, 100%. Yeah.
Cool.
Thank you. All right. Great to chat. See ya. Take care, Ahmad.
Bye.